students, today we are going to explain next topic, like next chapter. The chapter name is carbon and its compounds. So let's start to this topic now. If we talk about to the carbon and its compounds, then first of all we can say it that carbon and the hydrocarbon like, it means all the compounds which is connected with the carbon, that will be the hydrocarbon. Okay, so first of all, the first topic which is related to the carbon is bonding in carbons. So students, as you know, carbon have the properties like that carbon forms covalent bonds. Okay, they have the property like that carbon forms covalent bond. What is the covalency? All of you know about to this. It means the number of electrons contributed by an atom for sharing of known as its covalency. It means when the carbon is, if we take one example to explain this, then we can say it like this. If the regarding the covalency, we take the example of HCl. Okay, so the number of the atomic number of hydrogen is 1. So the configuration is 1s1, or according the Bohr-Bury is 1. Okay, and chlorine, the atomic number of chlorine is 17, and the electronic configuration according to the Bohr-Bury rules is 287. Okay, so how hydrochloric acid is combined to each other? It is combined as one, two, three, 4, 5, 6, and this is the 7. And the electron of hydrogen is this sign. This is the electron of hydrogen. According to the covalency, it is forms like this. It means hydrogen have 2 electrons. Okay, and chlorine have 8 electron like this: 2, 3, 4, 5, 6, 7 and 8. It means chlorine have complete their octet and hydrogen have complete their duplet. So hydrochloric acid forms covalent bonds. Okay, clear it is? Now we come to the next topic, allotropy in carbon. So student, as you know, carbon have having the both the properties. They have shown more than two properties or more than two properties. It means the properties due to which an element exists in 2 or more forms. It is known as allotropy, and the various forms is called allotropes. The example of carbon which is the allotropes to each other is carbon exists in 2 allotropic forms. First one is crystalline, which is known as diamond, and second one is amorphous, that is the coal. It means the allotrope of the coal is diamond. Okay, students? all of you know about to the unique nature of carbon. Carbon have unique nature because they have one of the good properties like catenation. What is catenation? All of you know about to the catenation. So if we want to describe about to the catenation, the properties of elements to forms long chain, that is called catenation. It means they have forms more and more long chains. This is why we can, and these properties have only the unique properties carbon atoms only. These properties having only a single elements known, that is the carbon. Okay. Next topic is saturated and unsaturated carbon compounds. This is the most important topics. So students, if we talk about to the saturated carbon compounds, then we can say it, any compounds which forms with the single bonds, that is called saturated compounds, like this. Saturated compounds. It means CH4, C2H6, etc. It means this is the methane, and carbon bonded to each other with the single bonds look like same. Second one is the ethane, and it is also bonded to each other with the single bonds. And the general formula of the saturated carbon compounds is CnH2n plus 2. General formula is CnH2n plus 2. Here n is number of carbon atom. Okay students. So if we put the value like in the case of carbon atoms, it means in the methane, for the carbon the number of carbon atom is 1. When we put this value in this formula, then we get first member of the carbon saturated carbon compounds. Look like this: C1H2 into 1 plus 2 is equal to what? C1 means C, and 2 into 1, 2 ones are 2, plus 2 is equal to 4. It means CH4. Clear? Clear to everyone? And second one is the unsaturated hydrocarbons. If there will be forms double bond and triple bond like this, then this will be called unsaturated carbon compounds. The example of double bond and triple bond is unsaturated carbon compounds. For double bond, double bonds. It means between the carbon there will be double bond. Okay, this is look like. What is the journal formula of in the case of double bonds in unsaturated carbon compounds? You know, the journal formula is CnH2n. Cn Cn H2n. Example, C2H4. It is, what is this? You know, this is the ethene. Now, if we put this example in this formula, the number of carbon atom is 2. So, if we put this in this formula, C2H2 into 2 is equal to how more? C2H4. Okay. And the structure of the ethene is, and it is called ene. It is called ene. This is, if we use the suffix and prefix, then we can say it, the, if there will be the number of carbon atom 2, then it will be the 8th, and if it will be the double bond, then it is called ene. So the name of this compound will be ethene. Clear? Clear to all students? And the structure of C2H4 is what, you know? This is C2H4. Clear? Clear to everyone? So for the double bond, we take one example like the ethane, and this is their structure and this is their name. Clear everyone? Now we come to the unsaturated carbon compounds. For the triple bond, it is look like for triple bond, the example is C2H2, and the journal formula is CnH2n minus 2. If we put the value of carbon atom n equal to 2, then we get to this formula as C2H2 into 2 minus 2 is equal to what? C2H2. Clear to everyone? And the structure of and the name of this compound is, if the number of carbon atom will be 2, then what will be? It will be the 8th. And if the formula is CnH2n minus 2, then it is used for triple bond ene. So the name of this compound will be ethyne. Clear to everyone? Clear? And the structure of the triple ethyne is, you know, the structure of the structure of ethyne is C triple bond C H H. This is the structure of ethyne. How? Clear everyone? So we come to the next topic. Straight chain compounds. You know about to the straight chain? You know about to the straight chain? If any chain will be the long chain, then we can say it. This is the straight chain. The example of straight chain is, if we take one example like C4H10, this is the butane, like the alkane. This is the butane. If we talk about to the straight chain, then we can say it, the structure of the butane is look like C, C, C and C. 1, 2, 3 and 4. And number of carbon atom is 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. This is the structure of straight chain compound butane. Clear everyone? And all the carbon and hydrogen atom is saturated with a single bond. So we can say it, this is the saturated carbon compounds. And next, branch chain compounds. If we take same example like the butane, C4H10, if it will be the branched chain, then the name of this compound will be the isobutane. Isobutane. And the structure of isobutane is look like this: CH, CH3, CH3 and CH3. If we count the number of carbon atoms and we count the number of hydrogen atoms, it will be completely follow this rule. Number of carbon atom will be 4 and number of hydrogen atom will be 10. How? Number of carbon atom is C is equal to how more? 1, 2, 3 and 4. So we can say it, the number of carbon atom is in this compound how more? 4. And number of hydrogen atom is how more? 3, 4, 4 and 3, 7 and 3, 10. So number of hydrogen atom is 10. Clear to everyone? So what is the name of this compound? Isobutane. Clear everyone? So next day I will explain to the next topic. Okay, thanks.